Good morning, good afternoon, everyone. This is a review for our Unit 1 test that's coming up on Tuesday. What I'm going to do is I'm going to go over a few of the problems that you're going to see that you're going to have to complete on your review. So these are gimmies, meaning you should get all of these questions correct. The intention of this review is for you to be able to reference it or use it when you take the test on Tuesday. So make sure that you're paying attention. If you need to stop the video and process what's going on, make sure you do that. And the review needs to be completed on paper and pencil. That is going to be an assignment. And what's going to happen is, let's say you don't get the score that you want on the test. This review and you completing the review showing all the work is going to be required in order for you to be able to make up that test grade. Okay? So first one is comparing rational numbers, right? And the relationship between rational numbers. So what I'm going to do is I'm going to draw the organizer so that you can see it. And then I'll go over these answer choices. So I'm going to draw it down here in the bottom, right? So that you can see it. So follow along with my little organizer. So all the numbers that are going inside of this box are real numbers, right? Then we're going to have two circles. We're going to have a big one here, and then we're going to have another one over here, meaning those two numbers are separate. Those two types of numbers are separate, or they don't belong together. And then over here, we're going to have another set of numbers, right? And I'm going to label each one of them for you. This was something that we did on the first week. If you go back to the first week's resources or notes that you took, you should have all of this information. So the first of all, again, all of these numbers inside of this box are real numbers. Then this first set of numbers here, we call these rational numbers. These are numbers that can be written as ratios. So forgive my poor writing, right? But that's rational numbers. So any number that can be written as a ratio that doesn't have a denominator of 0. So for instance, 1/2 is a rational number. 0.5 is a rational number. Let's say the square root of 4, which equals 2, is a rational number, right? Then the next set of numbers are integers. Integers, I'm going to do my best to write it there, and I'm going to put integers up here. They're negative whole numbers, 0, and then positive whole numbers. The important part about integers is they have to be whole numbers. So negative whole numbers, positive whole numbers, and 0. And then last but not least, I'm just going to put a W in here for whole numbers, right? And then whole numbers are pretty obvious. So 0, 1, 2, 3, 4. Now in this other little circle off to the side, these are irrational numbers. I'm going to put IRR for irrational. Irrational numbers are numbers such as pi and numbers such as certain square roots that have non-terminating decimals, meaning they go on forever. Like, for instance, the square root of 2. We've gone over all this. This is just a review, okay? We should know this by now, hopefully. Now, the question asks, which Venn diagram correctly represents the relationship between whole numbers and rational numbers? So we have to go through each answer choice. So let's go over A. So A shows that yes, all the numbers inside that box are real numbers. So technically that's true. But what it's showing is that rational numbers and whole numbers do not have any numbers in common, right? So what that's saying is that's saying that rational numbers, we talked about numbers that can be written as a ratio, and you can write a whole number as a ratio by putting a 1 underneath it, right? It's not the same thing, or they don't have numbers in common, such as the number 2, right? Those are both ratios, or those both can be written as rational numbers, and those are both whole numbers as well, right? So A is not it. B, it's showing that all those numbers are real numbers, and it's showing that some numbers overlap between the rational numbers and whole numbers, right? Technically, all whole numbers are rational numbers because all whole numbers can be written as a ratio. So 2 is a whole number, can be written as a ratio. 3 is a whole number can be written as a ratio of 4. Whole number can be written a ratio all the way to infinity, right? So not some of them, all of them are also rational numbers. So B is not it for us. Let's go to C. C says because all whole numbers are also rational numbers. And we just talked about that. Because all whole numbers, let's say 4 can be written as a ratio of 4 over 1. 5 can be written as a ratio of 4 over 1, right? So all whole numbers are rational numbers, and all rational numbers are real numbers. If you can look back to this little organizer that we made over here in the right-hand corner, that'll kind of help guide your thinking. We're going to continue on to the next problem, and we're going to look at the next problem that's also comparing rational numbers. It asks which Venn diagram correctly describes the relationship between set R and set W. When you're doing this type of problem, right, they're telling you R equals real numbers and Z equals integers. So this is just like the last one, but they try to confuse you a little bit by using letters to represent real numbers and integers. So we're just going to go through every choice and we're going to see which one shows the correct relationship. So F, because all integers are real numbers. So yes, all integers are real numbers, right? So we'll just check mark that one. So technically that's true. G, because all real numbers are integers, right? That's not true because there are some real numbers that are not going to be integers, right? For instance, the number pi is not an integer. Remember, integers have to be negative whole numbers, 0, or positive whole numbers, right? So all real numbers are not necessarily going to be integers. H, because some integers are not real numbers. So remember, integers, -2, -1, 0, 1, 2. Those are all real numbers, right? So H is incorrect. And then J, because integers and real numbers have no elements in common. All integers are real numbers, because if we look back at those numbers, those are all real numbers. So our answer, the correct answer, should have been F. Now notice, even though I felt like F was the correct answer, I kept going on to the next one, and I went through every single answer choice. Next up, we're going to convert between standard decimal notation and scientific notation. So if we're looking at this number, if we're looking at number 1, the density of silver is 0.001049 in grams per cubic kilometer. How is this number written in scientific notation? I'm going to write it a little bit bigger so we can see it and we can play with it a little easier. So 0.123. Now remember, when you're working these out on the test, I don't care if it's on the computer. You need to write them down so that you can work with the number just kind of like I did right here. Our first thing is we can do one of two things. We can move the decimal from where it's at, or we can find the first non-zero number. For me, I'm going to look for that first non-zero number, which is 1, right? I'm going to move that away from there. I'm going to put a decimal next to it, and then I'm going to count how many powers of 10 or how many place values it's going to take to get to that decimal. So there's 1, 2, 3, 4. So this is going to be 1.049 times. We have to ask ourselves, is this number, is it getting bigger when we change it into these numbers, or is it getting smaller, right? If it's getting bigger, that means that we're dividing, or our exponent is going to be negative, right? So we counted 4 powers of 10, so that's going to be times 10 to the -4th, right? So let's recap what we just did. We found the first non-zero number. We put a decimal place there, and then we counted back to see how many places it was to the decimal that was already there. So there was 1, 2, 3, 4 powers of 10. Now you could have done it the other way. I'm going to use blue to show you the other way. You could have started off where the decimal was, and then you could have counted how many powers of 10 it's going to take in order to get to after that first non-zero number. So 1, 2, 3, 4, and that's 10 to the -4th. Now, number 3, the mass of a textbook is approximately 0.00001 137 metric tons. How is this number written in scientific notation? Same thing as the one before. I'm going to start at the decimal first, and we're going to go all the way to the first non-zero number. 1, 2, 3, 4. We're going to put our decimal there. Our number is going to become 1.37 times 10. And then remember, our exponent is going to be negative, because when we went from this number to this number, it got bigger, right? So it means that we're dividing, or we're multiplying by a negative exponent. So that's 1, 2, 3, 4 powers of 10, which is going to be -4. Last but not least, the mass of an African bush elephant is 13,000 pounds. How is this number written in scientific notation? So I'm going to write it bigger so we can play with it. And then we are going to find the first non-zero number. The first non-zero number is 1, right? I'm going to get rid of that just so we can see it. We're going to put a decimal there, and then we're going to count how many powers of 10. 1, 2, 3, 4. So this is going to be 1.3 times 10 to the +4. Now I want you to notice the difference between what we did in number 4, where we went from a bigger number in 13,000 to a smaller number here, and how we had a positive exponent, right? Our exponent, our power, was positive, versus when we went from a decimal, a number less than 1, right? We talked about these numbers being greater than 1, these numbers being less than 1, and how when we took that number that was less than 1 and we went to a bigger number, how that made our exponent negative, right? We're dividing there, and so therefore our exponent is negative. Next type of problem that we're working with is going to be ordering and comparing rational numbers. Now, these are going to be easy for us because we're allowed to use calculators in 8th grade, right? You should still be able to do all these things using paper and pencil, but you're going to go, if you have your own calculator, use it. If you want to use the calculator that's on your MacBooks or your whichever kind of device you have, you can use those, or you can go into Google and you can Google calculator. And if you Google calculator, one's going to pop up right on the screen. And what we're going to do is here, it's asking us which list shows the runners in order by their completion times from fastest to slowest. We're just going to go through each one, and we're going to convert every number into a decimal, or into decimal form. So the first one, Sonia, 19 3/5 seconds. So we know that the whole number is 19, and then we're going to convert 3/5 into a decimal. That means 3 divided by 5, top dog goes in the house. So if I divide 3 by 5, I'm going to get 0.6. Again, you can use the calculator to do that. Next up, Caesar. We already know Caesar's 19.7. Next up is Stacy. We have Stacy is 19.75. And then the last one is Roberto, 19.5. And we should know by now as 8th graders that 19.5 is 19.5. Or if you want to do the math, 1 divided by 2. If you do it, it's 19.5. Now next we have to order these. So I'm going to draw a number line. Some of you, the number line will help because you're visual learners and you need to see it. And some of you guys will be fine without the number line. But I like to use the number line. I want to see what number is the smallest number, or it wants to know fastest, meaning fastest. For instance, fastest is going to be the smallest time, right? The quickest time. So the quickest time is 19.5, which is Roberto. Next, the next fastest is going to be Sonia at 19.6. So I'm going to put Sonia. I'm going to do Sonia in a different color so we can see it a little bit better. 19.6. Then the next one is going to be Caesar, because Caesar completed it in 19.75. I'm sorry, 19.7. And the last one, I'm going to do the last one in black. We'll say the last one is Stacy, and Stacy did it in 19.75, right? So let's backtrack everything we did. We converted all the numbers to decimals. Then we took those decimal numbers and we placed them on a number line from fastest, which means the smallest time, to the biggest time, right? Sometimes it's going to say fastest to slowest. Sometimes it'll say least to greatest. Sometimes it'll say ascending to descending, right? Those vocabulary terms are important and you should have them. Next up, Next up, the number 2, the diagonal lengths of 3 rectangles are shown. The rectangles are not drawn to scale. Which list shows the rectangles in order by their diagonal lengths from shortest to longest? So the first one is already given to us in decimal form. Remember, we need to write these as decimals. So the first one, 8.55. We know that. The next one, the square root of 65. You're going to have to do this on your calculator. On your calculator, you're going to put in that square root symbol. Then you're going to type the number 65. So the square root of 65, and then you'll hit the equal sign. It tells us it's 8.062. And then here, 34 divided by 4. We're going to use our calculators again. 34 divided by 4 equals 8.5. So from there, we're asking ourselves, it wants to know from shortest to longest, right? Shortest to longest. So we're asking ourselves, which one's the shortest? If I'm looking at them, this is the shortest, right? So this was rectangle G. And then I can look at all the answer choices and we see that G is the only one that shows rectangle G is the shortest. So at that point, I could have finished the problem, but I like to do everything all the way. Then we can see 8.5 is next up, right? So 8.5. And then next up would be rectangle F, right, at 8.55. Notice I had to do all of them because this rectangle and this rectangle were super close. One was 8.5, the other was 8.55. So last one, mean absolute deviation. Determine the mean absolute deviation for each set of data. Round to the nearest hundred if necessary. Then describe what the mean absolute deviation represents. So first of all, we're going to have to take and find the mean for the cost of video games, number 1, which means you're going to have to add up all of those numbers, right? We're going to add them all up and find the sum, and then we're going to divide by how many numbers there are. So if there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we're going to have to find the sum of all those, and we're going to divide by 10. So when I add all these up, the sum is 497. So if I divide 497 divided by 10, then I get 49.7. So that's our mean. Our mean is 49.7. Next, we're going to have to go through each number and find the absolute difference between each one of these numbers and the mean. So we'll start off with that 40. I'm going to write all the numbers here on the side. 40, 55, 60, 48, 57. You're going to have to do this work, guys. It's annoying. And honestly, there's a way that we can do them on the graphing calculators. I'm going to teach you that a little later in the year just because I want to make sure that you understand how to do it. And then once you're able to do it on the calculators, it's going to be super easy for you. So if we are finding the positive difference or the absolute difference between the mean and that number, we're going to take the mean and we're going to subtract each one of these by the mean, right? Or we're going to subtract the mean from it. Next, after we find the positive difference between each one of those numbers, the cost of the video games and the mean, so notice 40 minus 49.7 equals 9.7. 55 minus 49.7 is 5.3. 60 minus, so I'm going to go through and I'm going to find the difference between each one of these numbers and the mean. Once I have all of those numbers, I am going to take the mean of all of these numbers, which means I'm going to have to add them all up and then I'm going to divide by how many there are. So if I add up all those green numbers or all those numbers that were the positive or absolute difference between the mean and the cost of those video games, I get 178. If I add them all up, I get 178. And we need to find the mean, which means I'm going to divide by how many numbers there are. Remember, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if I divide that, it's 17.8, which means the mean absolute deviation, or the MAD, equals 17.8. So what that means is for each one of these numbers, those costs of the video games, the average distance between the cost of the video games and the mean, the average distance between those numbers and the mean is 17.8. It's a long drawn out process. If you just do the steps, use the calculator, it's gonna make your life easier, then you should be fine, right? I'm gonna allow you to do number 2 on your own. This video will be up on YouTube. You need to complete the rest of the review. I did about half of it for you. It is due today, and then we're gonna take the test on Tuesday. Good luck. May the force be with you.